Okay, so I said I was going to show you how to do all of this from right within the Mover software. So what you want to do in the main window is go right click, add, and the first thing you want to add is a source, which is a loop. So click loop and you'll get this window up here. Pick longitudinal acceleration, doesn't really matter what you're taking, it really doesn't matter. As a wave type, square, amplitude 0.5 units and vertical shift 0.5 units. So it starts at 0.5 units and then it goes half a unit up, half a unit down, half a unit up, half a unit down. So it means the signal is going to alternate between a 1 and a 0. So this one here is initially just a value, so there's no filter being applied. Period 5,000 milliseconds, all fine. You see here the value is still 0, but as soon as you connect, it fades this value in. And now it starts to show up, and there you have it. It's a 0, and then 5 seconds later it's a 1, and another 5 seconds later it's a 0, all fine. So the next thing you want to do is go right click, add viewer, and then a graphics viewer, and it gives you this window. So I've made the setup already, so take a horizontal scale of 30 units, a vertical scale of 200, at least in my case that was what worked. Just tweak it around until you have a nice scaling. And under source, you see the loop that we have just created. So within this thing, take the original longitudinal acceleration, and you can take a look at our step signal that we are generating with this square wave. So it's probably a bit of a short step. So you might want to lengthen this to 30 seconds, 30,000 milliseconds, and it's going to take a little while for this data, for the old data to leave and the new data to show up. So what you can see here now, the signal is 1, and then 15 seconds later it's going to drop down to 0. So now what we're doing, it's all an unfiltered value, so it's just the pure value. So let's take a look at the filter value. So we can go here, and then we select the EMALP. It stands for exponential moving average low pass. As I said in the last video, there's a reason why we're using the exponential moving average low pass, because that's the only one that gives us the properties that we actually want. I've tried plenty of others, and there's reasons why I wouldn't want to use them. But well, for now, you feel free to do whatever you want, but the exponential moving average low pass is the one that I think satisfies all criteria, and it's pretty simple. Okay, so here we have it. So you set this value here to 2000, and you're going to understand this later. So what we have now here is we've created this output value, and it's no longer just a simple 1 and a 0. See, so it gradually changes. So let's take a look at it in the graphics viewer. I have the original longitudinal acceleration, that's the 1 and 0, the step input, so to speak. So let's take a look at the output signal. I'm going to activate this. So let's take a look at what it does. If the step steps down to 0, that output signal will gradually approach 0. Asymptotically, it'll never really get there, just got very, 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 very close. And then 15 seconds later, you see the step goes from 0 to 1, boom. Step is up to 1, but the output signal gradually grows up to 1. As you can see here, it will eventually get very, very close, but I mean, at least theoretically, it'll never really get there. There's always a digit somewhere behind the comma that's not quite there. So this is a method to generate these curves and to take a look at these curves in Move to generate a step signal that goes from 0 to 1, 1 to 0, and then take a look at how that thing behaves. If I want to, well, maybe pique your curiosity a little, I could show you, instead of an exponential moving average low pass, I might as well show you, instead of using the low pass on the value, I might use a low pass on the low pass. And initially you should also use the same value. And now what you're getting here is a very, very similar curve. It's just that, like I said in the previous video, the first low pass makes a non-steady signal into a steady signal, but it gives a corner. The second rounds that corner off. So the second order low pass that we're having turns the corner into a tangent line. And the next one would eventually create curvature continuity or a curvature gradient. And then the next step on top would be a jerk derivative limited function. So yeah, I definitely recommend to try this out, try playing around with different low-pass filters and try to see what the corresponding curves are. Let's put this back to a simple low-pass filter. So now we're back with just a simple low-pass filter. It's going to take a little while for this, or it's going to take at least one cycle for the signal to stabilize. Now what I wanted to show you was why in the world did I put in this value 2000 and what does it really mean? So you might want to take a look here. Right click, options, and you get the options window and you see the calculation rate. That's 2 milliseconds, which if I take the inverse of that means we're operating at a 500 frames per second. So the time interval between frames is 2 milliseconds, 500 frames a second. So if I'm processing stuff at 500 frames a second, and take a look here, there's the filter variable, the 2000. That tells the algorithm, so to speak, that you want a gradient so that you would be on your target 2000 frames down the road, which means 4 seconds. So maybe I can pause this. Yes, I can pause this. So in this very moment, your output signal will take a gradient so that it would reach its target, which is in this case the 1, after exactly 4 seconds. Well, 4 seconds because a target horizon of 2000 frames into the future and 500 frames a second, all in all, will mean that you, in this very point, have a gradient so that you reach your target after 4 seconds. 2000 divided by 500. Now just play around with these values. If you increase your target horizon, these gradients will be shallower. If you decrease that target horizon, that filter variable, your gradients will be steeper, but you will never turn a corner into a rounded corner. That can only be done by a higher order filter, by a third and a fourth order low pass filter. So play around with it, try to reproduce these curves and see how they behave. I can only recommend to do that. I'm not sure if this goes too far, but eventually you're gonna have to face the question why in the world a low pass filter behaves kind of like an integrator and a high pass filter behaves kind of like a differentiator, at least in the short term. That is something that actually needs to be answered at some point. Not sure if you're interested in a video on that, so let me know if that's the case. And so I hope that I could shed some light on this whole filter thing, and I can only recommend understand filters and understand what's going on your vehicle, and then pretty much motion cueing becomes a piece of cake.